Now we're going to look at a problem dealing with a tessellation. Explain why a tessellation cannot be created using only regular octagons. Now a tessellation means a tiling of the plane. So that means we could take octagons, placing them next to each other, and end up covering the entire plane. Well, let's look at this algebraically. That is, what do we know about the sum of all of the angles in an octagon? Well, we know that that's going to be equal to n minus 2 times 180 degrees. So the n is going to be the number of sides in the octagon, that's 8. So we're going to have 8 minus 2, which is 6. 6 times 180 degrees is going to equal 1,080 degrees. Well, we're talking about a regular octagon. So let's look at one angle in that octagon. That's going to be the sum of all of the angles divided by the number of angles, which is 8, and that gives us 135 degrees. Now, we know that if we're going to have a tessellation, then where the vertices meet, let me just go ahead and kind of quickly sketch that out. Wherever the vertices meet, they all have to meet together, and that would form 360 degrees all the way around. Now, let's see if we can make that happen when we have an octagon coming together. So we're going to have 360 degrees. We're going to have to divide that by 135 degrees. The thing is, that does not come out to be even. It's going to be 2 2/3. Now, what that pretty much indicates is that we'd have to have two angles at 135 degrees. Those would come together and give us 270 degrees. But if we try to add now another 135 degree angle onto that, we're going to end up with 405 degrees. That's going to be too large for one full revolution. So what would occur is we'd have very large angles coming together. Let me kind of quickly sketch that out. That'd be one of them. And then we'd have another one coming in. This would be 135 degrees. This would be another 135 degrees. And then this measure is going to be too small to fit another octagon in. And so for that reason, we're not going to be able to create a tessellation.